Hello and welcome to our final polynomial subseries video, and in this episode we're covering factor theorem and long division, that is of polynomials, obviously. This is our final polynomials episode, and we're going to cover the new bits, not any more recap from GCSE. Let's get on with it. So, this explains factor theorem. Now you see any polynomial can be written in the form of ax plus b times by cx plus d, etc., depending on whether it's x squared, x cubed, x to the 4, etc. However, what the factor theorem states is that if you substitute in a value m and it equals 0, then x minus that m value is a factor of the polynomial. For example, f of 4, if f of 4 equals 0, then x minus 4 is a factor. And we do this by choosing factors of the final independent term. Remember, independent just means without any x in it. Now this is the method. So say we have this expression, f of x equals x cubed plus 2x squared minus 3x minus 10, a lot more than our usual quadratic. We must list out all possible factors of the n/independent term, which is minus 10 in this case. So we have 1, 2, 5, 10, and then all the negatives. But I suggest you check the terms closest to 0 first. So f of 1, you get minus 10. That's not right. But if you do 2, it does work out to be 0. And so therefore, you can then just state simply on your paper, therefore, x minus 2 is a factor. Those three little dots mean therefore if you don't know. But you always have to then do the other three little dots because of the factor theorem. Now that we have that one factor, we can then use long division of polynomials to separate it out and get ourselves a quadratic remaining. So let me show you how to do this. So here's our example one from earlier, and here's our x minus 2. First, we need to multiply that x minus 2 by something to get it to match that first two terms. And in this case, you always match the x to the first term. So usually this means just multiplying by x squared, like I've done here. X times by x squared is x cubed, minus 2 times by x squared is minus 2x squared. You then write what you've multiplied by at the top and subtract it away from the total. This cancels out the x cubed term, and you're left with this. 4x squared minus 3x minus 10. From here, you then repeat. What do you do to get from x to 4x squared? Well, you times it by 4x. So you do the same to the minus 2 as well. Subtract it. Write down what you've multiplied by first, then subtract it, and then get the remainder. And then you can clearly see that's just a multiple of 5. So you write it out, plus 5, and then subtract it off to get 0. So now you're left with that whole expression is just equal to x minus 2, x squared plus 4x plus 5. Now that can't be simplified. However, sometimes they ask you to fully simplify these cubics in exams. So that's what we're going to go over next in our practice questions. So here's our first practice question. Solve the equation 2x cubed minus 7x squared plus 2x plus 3 equals 0, giving your answers as integers or fractions. Now, the first thing we are going to want to do is to use the factor theorem. So let's start by writing out the factors of the term 3. And it's literally just 1 or 3. We only have those to check. So I'm going to box them. so we don't forget it. And we'll start by checking 1, as that's closest to 0. So f of 1 is equal to 2 times 1 cubed, take away 7 times 1 squared plus 2 times 1 plus 3. And what does that equal? 2 take away 7 plus 2 plus 3. And that equals 0. So that we know that this is the right one, and we write x minus 1 is a factor. How do we know this? Because of factor theorem. Now we must divide. So we say it out. Here's our original equation. Here's the factor we found. And now we're going to start dividing. So what do we multiply x by to get 2x cubed? We do multiply by 2x squared. And then that's minus 2x squared. Subtract it. Those cancel out. You do minus 7x squared plus 2x squared because it's negative twice. So you get minus 5x squared plus 2x plus 3. We repeat. What do we multiply by? Minus 5x. We subtract. 2 minus 5 is minus 3x plus 3. What do we multiply by? Minus 3. And then we get to 0. So this is what we're left with. We can now rewrite this as x minus 1, 2x squared minus 5x minus 3. But I think we can still factorize this. So let's take it off to the side over here. How do we factorize normally? We take the minus 3 times 2, so it's doing minus 6. We split it apart. We have plus 1 and negative 5, which negative 6, sorry, that equals negative 5. So this is the combination we're using. And then we're going to split this apart into 2x squared minus 6x plus x minus 3, then factorize 2x, x minus 3 plus 1, x minus 3, and then finally 2x plus 1, x minus 3, which we can then take back up there and fully complete it as x minus 1, 2x plus 1, x minus 3, and that's equal to 0, because we're still solving. So we want answers as integers or fractions. We split each bit up. We have x equals 1, x equals minus 1/2, and x equals 3. And those are your answers. Okay, for our second question we have find the remainder and quotient when x cubed minus 3x squared plus 5x minus 10 is divided by x minus 4. Now this is actually a style of question that's already come up in previous exams. I think it's 2022 or 2023. So it's best to be prepared for this kind of thing. Now quotient here is whatever's left over if it does not divide neatly, if you're not left with 0 in the end. Quotient is what came out, what was the product, what was at the top. Remainder is what was left over at the bottom. So let's start by writing out the division. We have x cubed minus 3x squared plus 5x minus 10. And we're dividing it by x minus 4. What do we multiply x to get to x cubed? Multiply by x squared subtract, cancel out. Minus 3 plus 4 is 1. What do we get from x to x squared multiplied by x? Five plus 4 is 9. And then we multiply by 9 to get this cancelled out, and then minus 10 plus 36 is 26. So the quotient is what we have up here. You can just do q equals x squared plus x plus 9, and then remainder r is equal to 26. And there's your answer. Welcome to our 4-mask segment of this video. For those who don't know, this segment is where I give you 4 questions on each of the different aspects of this one topic. So for today's, it's factor theorem and long division. So we have the pure mask, the applied mask, the proof mask, and the riddle mask. Choose any one of them, or all 4 of them if you're feeling mathsy, and have a go at them. I have them on my worksheet if you would like to do them on there. And then come back to the video when you're ready to see the answers. Okay, so let's first look at the pure mask. Now this is a pretty simple question, basically the same as what we've been doing throughout the rest of the video. Literally just a proof that x minus 3 is a factor by substitution back in. So it's like reverse factor theorem. And then long division separately. And as you can see, the answer is x minus 3, x squared minus x minus 10. Now for applied, it's a bit different. You have to take out the negative from the factorization. It just makes it a lot easier, because then that negative can just be completely just ignored, because it's basically a minus 1. Divide 0 by anything, even minus 1 is still 0. Make sure you don't include the x equals negative 2 in your final answer, because you can't have negative 200 units. So it's just x equals 2 and x equals 6. For proof, this is a very hard question in my opinion. Proof is usually the hardest of all the bunch, but this is definitely one of the hardest proof questions we've had so far in this series. And there's the simple version and the complex version. Complex does it in less words, but simple is basically just our knowledge around, any polynomial is written as a form of 2 brackets multiplied, and therefore you can separate out the brackets, and that each bracket is going to be 0 when you substitute x for whatever else was in that bracket. Complex version, it's factorizing out that bracket instead, just with some fancy notation, and then saying that if that bracket's equal to 0, it's going to be when x equals a. Finally, for the riddle mask, it's a bit harder than the usual riddle question. Not too bad. You just have to substitute in everything at first. So f of 3 equals 0. You substitute 3 into all of those x's and then set it equal to 0. Same for f of 1 equals 4. And it's given to you that a equals 1, so you don't need to worry about what coefficient of x cubed is. So you're just working out what b and c are. So you do that by subtracting the 2 equations you formed, like they're simultaneous equations. And then you just rewrite the whole thing out. So you should have gotten x cubed minus 4x squared plus x plus 6. Thank you for watching the video. The next video will be a short video on quite a small topic really. It's going to be on objective functions. If you want more work on this topic, feel free to check out the worksheet if you haven't already in the description. Let me know if you have any suggestions that you want me to cover in the coming weeks in terms of videos in the comments, or if you have any questions. I usually respond for like another week after if you have any questions. This week's half-termly article, as always, is on how can we best teach maths and how does a student respond. So feel free to check that out. That's also in the description. Thank you for watching again, and goodbye.